Hi, I'm Kamaksha Masunuru. In this video, I'm going to talk about how to deal with missing data using R programming language inside RStudio editor. I'm just going to deal with the core basic, core logic. I'm not going to talk because dealing with missing data in R is a big subject and it requires hours of study, also preparation. There are quite a few packages. Few of the most important packages are, I don't know what is this. Okay, few of the most important packages are mice, Amelia, Miss Forest, HMISC, HMIScellaneous, I don't know what it is, MI, and MI seems to be one of the good solutions for this particular aspect of the data analytics, which means missing data. So each package offers a set of strengths, and probably, I don't know if time permits, I may able to do a couple of other videos in which I can explain how to use these packages. But in this video, I just want to talk about the core logic. This means like today I'm trying to solve this. I'm trying to deal with missing data using R, but tomorrow I may be using Python or maybe Java. So the logic is very important than the packages and all. That's good. Like suppose if I'm developing an application by using R Shiny, or then I have to be thorough of packages, and maybe I can write my own package or something like that. But in this video, I decided to talk about the core logic, and the logic is like this. Apart from the logic, so there are some steps. I'm going to show you how to simulate data, and then how to there are different ways to deal with. I'm not talking about the theory of missing data. Like there are different types of missing data, and there are different ways to deal with missing data. So the types, actually, the missing data may result out of the system error, or maybe sampling error, or maybe if it is a survey, then maybe sampling error. If it is hardware components, if the data is streaming from the hardware components, maybe that may be system error. Or and there are different types, like the missing data at random, and missing data at non-random, or kind of. And as far as the strategies are concerned, we can deal with missing data by two ways. And the first way is to delete. So suppose if it is called deletion. There are two ways to delete. Either we can delete the rows or columns. So it all depends on the affordability of the researcher. And the other method is imputation. So here we have so many techniques. One of the simplest technique is the mean substitution or median mode substitution, and there are other methods like a case-wise substitution. Just like I can pick up a most generic case and then substitute, or I can take most similar, the case which is more similar to the case to which the missing data is, and then there are predictive models where we can use some regression. Simple linear regression, non-linear regression. There are some machine learning algorithms we can handle the missing data with few machine learning algorithms like KNN, random forests, or maybe, I don't know, like with cluster analysis, or kind of. So predictability is in focus. Like when we talk about the predictive models, right from the simple linear regression, it ranges from simple linear regression to the highly efficient algorithms like KNN kind of algorithms. So in this video, I'm just going to show you how to handle the missing data with mean substitution. Okay. So here there are so the step number one, simulating data set. I'm going to simulate the data sets because I don't have the real-time data sets, and that's not going to work for me for tutorials. Okay. So this is just a simple a demonstration where I don't need to have the. So I'm just simulating by using a function called matrix. This is my data matrix. I can call DM. I thought MyDM is a suitable word for this matrix. So what I'm doing here is that I am using normal distribution for simulating data. I'm also using another function called absolute so that I can get rid of the negative values. Usually so suppose if I use R norm and 10, it will have the mixture of the positive and negative values. So I don't want the so for this scenario I can even have the negative data, it doesn't matter, but I thought I should avoid negative. So if that is the case to you, better you use the function ABS, which might stand for absolute or something, I don't know. So I'm using few functions here. This statement is just going to simulate data from the normal distribution with a Pakka normal distribution, which means a distribution with the mean value 0 and a standard deviation with 1. I'm just multiplying each data point with 10 so that I can have 2-digit decimal number or something like that. And I want to have the 30 rows and 3 columns, just a simple data matrix. And then I will convert that into the data frame. So let's do this. So when I press Control Enter, this is a script actually, you can see here. So to execute the script inside the Control Enter, to execute the code inside the script, I have to use hotkeys Control Enter. Now I think R must have done something because it is silent, and now I can say head MyDF. Okay, so here this is the data. So this is the full data. So let me clear this, and I want to push this off. So if I is NA, okay, MyDF. So this is one of the commands available, false, 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 false. So right now I don't have the missing data. This data has full of. Now what I do is I just introduce some NA values. NA is actually the missing data. Wherever the data is missing, the system try to identify that data point with a valid data type called NA in everywhere, right? So I'm going to introduce some missing data. There are different. I mean, even in the packages which I have mentioned at the beginning of this video, in those packages there are some strategies as how to. These are all actually the testing purposes. Okay, we are not developing any application. That is, so for as a funny matter, I'm going to. This is actually a for loop. So what I'm doing is, for 1 to the number of calls. Like I have 3 calls, so you just try to, this is actually a function called RBinom. I'm using binomial data to create a vector. So this is what this is going to do is, let me show you what this happens. So if I execute this, what happens is there will be 30 different data points with 0, 1, something like that, 0 and 1, and with the 20% of the data, 20% of the data variable composing of 1, something like that. So let's 1, 2, 3, 4, 5. So 5 divided by 30, something like that. So roughly 20% of the data composing of a required response, something like that. So this we want to put this, the zeros and ones into this data frame for each variable randomly, and then pass this value NA wherever there is 1, something like that. So 3 times this statement will be executed because we have that inside for loop. So when I is 1, the variable 1 will be substituted with 20% of NA values. When I turns 2, then the second variable here. This is the second variable. Suppose if let me show you MyDF, and then this is first variable. Okay. And if I use 2, second variable. If I use 3, third variable. So when I turn for each value of I from 1 to 3, this statement is executed, is being executed, and when this statement was executed, roughly 20% of the responses will be substituted by NA. So let's see. So let's talk and more work. Now something happened. So let's go back and see MyDF. You see now there are NA values, and they're all substituted randomly. So that is why we want random or binom, something like that. Okay. So now let's enumerate how many of the values like overall kind of, I am using some function. There are different ways here. We can use call sums and we can use many other row sums and something like that. So I'm using overall, I want to see the total number of missing data points in this data frame, my data frame. So when I press enter, there are totally 14 data points. There are 14 data points. I don't know how many, like, maybe, may not be, like, I don't want to. So there are 14 total data points that are missing. So now what I'm going to do is, like, I'm just going to show you how to, suppose if I want to impute missing data in variable 1, then this is the strategy. So in variable 1, how many of the missing data are there? So if I execute this statement, so these are the missing instances inside the variable 1. How many of them are there? I can just, maybe, I don't know, I can sum up, or, so 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 instances. Now, what I need to do is, I'm going to substitute, so wherever you find, now, same statement, left assignment operator, then I'm telling here, this statement, what it does is that it computes the mean of that particular variable x1, and then see that that mean value go and sit exactly in the position where there are. So now if I press this statement, now something happened, and let's go back and see. You see now there is no missing data. So earlier there was some missing data. Here let's pick up one of the data. Sixth row we have in variable 1, sixth row, we have one missing data. Let's pick up here 1, 2, 3, 4, 5, 6. Now you see there is a mean, something like that. Okay, 6th, and again we have somewhere like 7th. Yes, there is a mean, and then this is perhaps, I don't know, like I should see mean, and then if I use mydf and variable 1 ma remove. So I want to remove this is the mean. See here. So wherever there is missing data, and there it is. This is actually the core strategy. So like that, we can just go ahead and do the same thing for variable 2 and variable 3, something like that. But that is not a good activity. So because we are using a programming language, so we need to use the assets of a programming language. So instead of doing this variable by variable, I'm going to use the for loop for each column in the data frame. Then you substitute the mean, the same statement. I just copied this statement and pasted inside a for loop. Now this loop, what it does is, when the variable is 1, for first variable, substitute the mean, and when I turns 2, second variable, substitute the mean of the second variable. Okay. So when I turns 3, and for the third variable, compute the mean for the third variable. And then substitute that. So instead of doing it variable by variable, we'll be able to do that at a shot by using loops. That is, in fact, the cool feature of it. That is why we need programming languages. Now, I already did some manipulations in the data frame, so let me go back and recalculate the missing data, and redo the entire work, so that this time there are 13 missing data points in the whole data frame. Now what happens, instead of doing it variable, I execute this loop. Now let's see, if I go back to mydf, you see you don't have the missing data, something like that. So I could have shown you wherever, anyway, so that doesn't matter. Like, we had, when we simulated the data, we had 13 data points that were missing, and in those positions, I don't know, like, if I look carefully, I may be able to find the, I think, is there any repeated value here in the first, I don't know, maybe, like, I can still find it, mean, mydf, and then x1, there are no, I think 7.67 should be, yes, so here, 7.67, so there were only 2 or 3 or whatever it is, like, so this seems to be the mean of the, so now the mean substitution have been carried on the existing data frame. Now this is also not a good idea. So because as I have mentioned, there are so many packages and each package has some methods. So let us make our own method. So this method, what it does is actually so we don't want to write the loops, and we don't want to, because everybody is not a programmer. So one of your friends, maybe colleagues or students, may not be programmers. So you can write the program and hand over this to them. So those people who don't have the idea of writing the loops and conditional statements. So what happens is we have a beautiful way of converting our logic into a function. So here this mean substitution is a function which has an argument called data. This is a data frame, and now what it does is this. I just took this for loop and pasted inside. That's it, nothing else. And then I'm just going to return that data frame once so this loop, I copied it here, and you know what is inside this loop. And then after it does all the substitutions, I mean imputation, and it is just going to return a data frame. That's all. Now I redo this. I say again similar, because all my data frame is filled with valid data. Now I have 15 data points missing. If you want to see, you can just my df. You see there are data points. Just as a matter of trust, I am just showing you. And now instead of I execute this function, so that this function will be available from the namespace of our programming language. And now this function should be there in my workspace or namespace, whatever it is. Mean substitution. Okay. Now what is the name of the data frame? MyDF. Now it returns the data frame. Okay. So earlier we had some NA values. I think the variable 2, the second row, we had NA, and now so this is how we can I just wanted to create a sample video with this issue that it has how to deal with missing data in our programming language, especially using RStudio. So maybe possibly in my future videos I shall talk about how to use linear regression, nonlinear regression, and a few machine learning algorithms to deal with missing data in R and RStudio. Thanks a lot for watching this video. Stay tuned for the new content. Press like button and subscribe to my video channel.